Hello friends, welcome to Civil Engineering Study and Construction channel. I am Devesh Bhattacharya here with another important session on civil engineering. Today we will discuss in detail the construction of RCC roof slab, including scaffolding, shuttering, reinforcement functions, structural behavior under stresses and moments, shear considerations, IS code references and material specifications. This video will help you to understand not just the construction method but also the science and engineering behind it. So let's start the main video. Before starting of an RCC roof slab, scaffolding and shuttering are arranged to hold the wet concrete till it gains strength. The centering and formwork should be rigid, properly leveled and aligned to the correct slope and dimensions as per the drawing. Indian Standard Code of Practice, that is IS 14687-1999, recommended good practices for centering and shuttering. The scaffolding used to support workmen and materials at height. Steel or timber scaffolding may be used depending on site conditions. Shuttering or formwork provides the shape of the slab. It should be tight so that cement slurry does not leak. Shuttering materials may be 12 to 18 mm thick waterproof plywood or steel plates. Surface should be coated with form oil for easy removal. Prop spacing not more than 1.2 meter center for timber, 1.5 meter for steel. The materials required for the slab construction are cement, fine aggregate, that is natural sand, coarse aggregate, that is stone chips, reinforcement steel and water. Cement may be ordinary Portland cement of 43 or 53 grade as per IS 8112 and IS 12269. This must be fresh and free from lumps. This is fine aggregate, that is natural sand. Sand should be clean, well graded and preferably from Zone 2. This is as per IS 383-2016. The coarse aggregate, that is stone chips, should be as per Indian Standard Code of Practice 383. The size must be 20 mm down, angular and hard enough. Water for concrete should be as per Indian Standard Code of Practice 456-2000. This should be potable quality, free from harmful salts and pH should be more than 6. Now going to the reinforcement steel. This should be HYSD bars of Fe 500 or Fe 500D as per Indian Standard Code of Practice 1786. This must be rust free, straightened before use. Reinforcement is placed as per structural drawings and Indian Standard Code of Practice 456-2000 provisions. Main reinforcement, that is bottom steel, provided along the shorter span of the slab. These reinforcement bars resist positive bending moments at mid-span of the slab. As per Indian Standard Code of Practice 456-2000, the minimum reinforcement should be 0.12% of gross cross-sectional area for HYSD bars and 0.15% for mild steel bars. Distribution reinforcement or top steel or secondary steel or binder placed perpendicular to the main reinforcement bar. These reinforcement bars controls shrinkage, temperature stresses and distributes load uniformly. Negative steel at supports, that is extra top bar. These are provided above supports to resist negative bending moments. In slabs of normal depth, shear stress is usually resisted by concrete. If nominal shear stress exceeds tau c, as per Indian Standard Code of Practice 456-2000, table number 19, shear reinforcement is to be added. As per IS 456-2000, the minimum cover for slab should be 15 mm or bar diameter, whichever is higher. Friends, the concreting of the RCC slab is going on. Let me say something about the structural behavior of this RCC slab. The slab acts as a flexural member. The maximum positive bending moment or sagging bending moment at the midspan of the slab. That's why we provide the main reinforcement at bottom of the slab. And maximum hogging bending moment, that is negative bending moment, acts at the support of the slab. That's why we provide the extra top bars near support. Maximum shear force acts at supports. As per Indian Standard Code of Practice 456/2000, clause number 23, span to depth ratio should not exceed 20 for simply supported slab and 26 for continuous slab. These are for deflection control. For a crack control, reinforcement spacing should not exceed 3D or 300 mm, whichever is less. Now going to the concreting. Mixed proportion should be M20 grade or higher grade as per IS 456/2000. Machine mixing should be as per IS 4926. Concrete should start from one end of the slab, maintaining uniform depth. Use of needle vibrator to avoid honeycombing should be done. Towel finish or broom finish depending on uses. Friends, using a vibrator during concreting is extremely important for ensuring good quality and durable concrete. Its main utility lies in compaction of concrete. I am stating here few points of utilities of using vibrator in concreting. It removes entrapped air voids from freshly placed concrete. It ensures the concrete fills all gaps and corners of the formwork. It eliminates honeycombing and voids, making concrete dense, and dense concrete develops higher compressive and tensile strength. It reduces permeability by removing air pockets. It prevents ingress of water, chemicals and salts, increases service life. It ensures full contact of concrete with reinforcement steel. It provides stronger bond between steel and concrete, enhancing structural performances. Compacted concrete settles properly, giving an even smooth finish, which reduces need for excessive plastering or surface repair. It helps in uniform distribution of coarse and fine aggregates. Excessive or improper vibration may cause segregation, so correct usage is essential. Indian Standard Code of Practice 456/2000 stated in clause number 13.3.1 that concrete should be thoroughly compacted and fully worked around the reinforcement, around embedded fixtures and into the corners of the formwork. Vibration shall be employed for compaction of concrete unless otherwise specified or permitted by the engineer in charge. So friends, this was the detailed process of RCC roof slab construction with scaffolding, shuttering, reinforcement, design consideration and material specification. I hope this video will help you in both practical field execution and exam preparation. If you found this useful, don't forget to like, share and subscribe to Civil Engineering Study and Construction channel. Press the bell icon to get regular updates on such important topics. See you in the next video with another important session. Till then, thank you.